always started off that way. Today we're going to work on chapter 6, simplifying fractional expressions. So when we say that term, simplifying fractional expressions, well, think about simplifying fractions. When we have something like 6 over 18, what we look for is a common factor, a number that goes into it. So there's a couple of ways that we can do this. We can divide it by, well, let's even say it. We can divide it by 2. That is a common factor. This is a common factor. 6 goes into 2 3 times. 2 goes into 18 9 times. But notice that this is not completely simplified. And we always want to simplify it not simplified to lowest terms. So therein lies, we can't leave that as our answer because it's still divisible by a common factor. Again, this is a common factor that goes into both of these numbers, 3 and 9. So 3 goes into 3 once, 3 goes into 9 3 times. Now this is simplified. And it's in its lowest terms. So notice that we chose to do common factors. We could also look at this problem and choose to use the greatest common factor. And the greatest common factor of 6 and 18 are 6. 6 divided by 6 is 1. 6 goes into 18 3 times. And notice in one fell swoop, we were able to do that. The other way to look at this problem is to break it up into factor pairs. If we break this into, well, technically 6, and if we broke 18 into 6 times 3, we again notice that we have that 6 ends up being our GCF, and they cancel because 6 over 6 is equal to 1. So a lot of students would look at this, they'd cancel the 6's and then put 3 in the numerator, but 3 is in the denominator. So that would be absolutely incorrect. That 3 needs to stay in the denominator. What's left? A lot of students do 0. That's not the case. Remember, 6 over 6 was equivalent to 1. So they don't go away, they just turn into 1's. So that's why my answer is 1/3. How do we find GCF? You can find the factor pairs or the GCF by prime factorization, etc. So what we're doing here is numbers. And what we really look for is values of 1, something over itself. So when we have 3x over 2x, we just break that into factor pairs. And we notice that x over x is going to cancel to 1, and that reduces to 3 over 2. So this simplifies into lowest terms as 3 over 2. If we get a little bit more complex and say 6x over 10x, well, we could write that as 2 times 3 times x, and we can write that as 2 times 5 times x. And the 2 over 2 is going to cancel to make 1. The x over x is going to cancel to make 1. And we notice that we are left with 3/5. So we do that. We're going to look to something of that nature where we can find a common factor, whether it be a coefficient or a variable as an x. And then the best one is now we have something like this, 2x plus 6 over 4x plus 10. Now you cannot cancel these constants. You can't cancel these 2's and 4's right here because these terms are being added and subtracted. Notice we could cancel these because they're being multiplied. When things are being multiplied, we can cancel like variables or like coefficients. But when they're being added and subtracted, that's not a good thing. We can't separate those. So we can't cancel the 2 and the 4. We can't cancel the x's. Nope, can't cancel that because these are being added and subtracted. We need them to be multiplying. So when we look at that numerator, we looked, hey, can I factor that? Can I turn that addition and subtraction into multiplication? Yes, I can find a common factor between 2x and 6. So I'll factor out a 2, and that becomes x plus 3. And then I'll look at the denominator, and I'll say, hey, can I factor that? Can I turn that addition and subtraction into a multiplication? Yes, I can also factor out a 2 from that, and I get 2x plus 5. So now we have a number or a coefficient multiplying. So now we can cancel those. Those cancel to 1, and that leaves me with x plus 3 over 2x plus 5. And that would be my simplified answer, because you can't cancel those x's because they're being added. You can't cancel, I guess that's the only thing that it looks like it would. So because they're being added and subtracted, we got to leave it like that. That is my simplified answer. So let's start checking a couple examples. So in this situation, we cannot cancel these. Even though they have 70s, even though they have an n, we can't cancel them. And we can't cancel the 70n and the 10n, even though they are like terms. We can't cancel it because of this addition. So we want to look at that numerator. And can we turn that addition into a product? Can I factor it? So I would go through my litany of things. Number 1, is there a GCF? 2, is it difference of squares? 3, is it a binomial square? 4, A times C. 5, factor by grouping, etc. All right, so we're going to do those things in order to factor that numerator. All right, does it have a GCF? Yeah, it has a GCF. It has a GCF of 10n. So if we factor out a 10n from 70n squared plus 10n, we get 7n plus 1 all over 70n. Now, this is being multiplied. We like that. This is really beneficial for us. Oh, let's not make it yellow because I've already used yellow. So we can do this. This is multiplying, and this is by itself down there. So how can I simplify that? Well, they both have a common coefficient. They have a GCF of 10. I can cancel that by 10, which becomes 1. And I cancel that by 10, which makes 7. And then they both have an n, and we can cancel that to 1. Right? N over n equals 1. So we've got 1 here and 1 here. And these are all multiplying. So the 1 times 1 just leaves me with 7n plus 1 in the numerator, and we have 7 times 1 is 7. That would be my answer. I cannot cancel the 7's because that 7n is being added to 1. So simplifying, I'm done. That is as far as I can go with number 1. Let's do another one. All right. So this one's a little bit interesting. We're still going to look in the numerator and denominator. We're going to tackle them separately. We're going to look at this, and we're going to look at this. So let's look at the top one. Is there a GCF? No. No GCF. Is it the difference of squares? Nope. Is it a binomial square? Nope. Can I do A times C? Yeah. So 1 times 45 equals 45. Factors of 45 are 1 and 45. 2, no. 3 and, what's that? 15? Yeah, hello, Mr. Mac. 4, 5, and 9. 6, no. Oh, no. 6, no. 7, no. 8, we're around the hoop. Signs are the same, both positive. We get 46, we get 18, we get 14. That's equal to my middle. So that numerator now becomes x squared plus 5x plus 9x plus 45 over x plus 9. Now we're going to factor that. We're going to look at the first two. We're still going to factor that numerator, and that becomes x plus 5. We're going to factor out a 9, x plus 5 over x plus 9. All right, they both have x plus 5, so I'm still factoring the numerator over x plus 9. Now they have a common factor. This is being multiplied, so I have x plus 9 over x plus 9, and they will cancel to make 1. So that leaves me with x plus 5, and that would be my answer. So this simplified to x plus 5, which is really cool to be able to see that. All right, that's because it's 1, and 1 times x plus 5 gives us x plus 5. And this stays as 1, and 1's in the denominator, so we're left with x plus 5. Let's look at number 3. Oh, and I didn't even do this. So we look at x plus 9. After we factored the numerator, we can't factor. There's no common factor. It's not difference of squares. It's not binomial square. We can't do a times c or factor by grouping. But we're looking at the numerator and denominator and seeing if we can factor them. So 48, I can't factor 48 at the moment. There's nothing that I want to break it into. 16b minus 8, yeah, there's a common factor. There's an 8 as a common factor. You get 2b minus 1. And now we see that we can simplify those coefficients, those constants. So what goes into, well, 48, right? I can do 6 times 8. So the 8's are going to cancel, and that leaves me with 6 in the numerator and 2b minus 1 in the denominator. Now that 2 and the 6 cannot cancel because it's not multiplying this expression in the denominator. That 2b minus 1, the 2 cannot cancel with the 6. A lot of students are going to try to cancel that, and you'll get it wrong. So be careful of that. That cannot be simplified. We would have to factor out and make it look like this, right? 8 times the quantity. Let's look at number 4. X minus 6, that has no common factor, can't be factored anymore. 5x squared minus 30x. I can factor out a 5 from the constants, coefficients, and I can factor out an x. So that leaves me with x minus 6. That's good because I'm going to cancel that x minus 6 with this x minus 6. Why can I cancel it? Because we're multiplying the 5x. So those cancel. What are we left with in the numerator? A 1. That's the tricky part of that. What are we left in the denominator? 5x. So that 5x is in the denominator. It needs to stay in the denominator. A lot of students will give me just 5x in the numerator. Doesn't all of a sudden pop up into the numerator. Number 5, numerator can't be factored. That denominator, so no GCF. I'm looking at this. I'm looking to see if I can factor it. No GCF, not difference of squares. Binomial square? Oh, close, but no. That second sign's negative, so not a binomial square. Let's do a times c. So 1 times negative 16. 1 and 16, 2 and 8, 4 and 4. Signs are different. Bigger is positive. Gives me 15, 6, 0. This is equal to my middle. So this now becomes x squared minus 2x plus 8x minus 16. I'm going to group. And I get 8 plus x over, I'm going to factor out an x, and I get x minus 2. I'm going to factor out an 8. I get x minus 2. So that equation now becomes, let's move you guys down a little bit. That's going to become x plus 8 over, they have an x minus 2 in common. Let's pull that out, and you're left with x plus 8. So x plus 8 and x plus 8 are going to cancel. You're left with 1 over x minus 2. Love it. So good. Number 6. Woo, Ooh, look at that. So we're going to tackle the numerator first. Let's factor that. So step 1, right? No, let's write that. Numerator. Not X. Hello, Mr. Mac. That should be n squared plus 2n minus 63. Some of you are going to get really good and be able to look at that and know that 7 and 9, positive 9, negative 7. But some of you will still have to do a times c. 1, negative 63, negative 63, 1 and 63, 2 no, 3 and 21, 4 no, 5 no, 6 no, 7, 8, 7, no, 63. 6. 6, yes. 6, 63. Fold down the 6. No, that's 54. 54, 7? 7 and 9? Oh, yeah, 7 and 9. Ooh, Mr. Mac's brain just went. Signs are different. Bigger is positive. That was really bad. Hey, you want it? Happens to the best of us. So that's always going to be careful and use a calculator if you don't know. So n squared minus 7n plus 9n minus 63. We're going to group. We'll factor out an n minus 7. Factor in a 9, n minus 7. We get n minus 7, n plus 9. So that was the numerator. So the numerator now looks like n minus 7, n plus 9. We turned addition and subtraction into multiplication. So that's beneficial to us. We talked about that a long time ago. Why do I want to factor? Why do I want to turn it into addition and subtraction to multiplication and division? Because it will allow us to reduce later on. So let's look at this denominator. What is a common factor? 7, and that is n minus 7. So what do they have in common? They can cancel out the n minus 7 and the n minus 7 because it's multiplying the n plus 9 and it's multiplying the 7. What does that leave us with? N plus 9 over 7. How fun is that? These problems are so awesome. They are challenging, they're super fun, and it's quite satisfying doing them. So let's take the numerator. Let's look at the numerator, n squared plus 12n plus 20. So we're going to factor 1 times 20 is 20. 1 and 20, 2 and 10, 3 no, 4 and 5. Signs are the same, both positive. And this is why we do so many, so we can just run through this pretty quickly. So n squared plus 2n plus 10n plus 20. We're going to factor in an n plus 2. Factor out a positive 10, n plus 2. And we get n plus 2, n plus 10. So this numerator becomes n plus 2, n plus 10. Let's do the denominator. The denominator is n squared plus 4n minus 60. No common factor, not a binomial square, not a difference of squares. So factors 1, 60, negative 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Signs are different. Bigger is positive. Lagging, you see that? Lagging. That gives me 59, 28, 17, 11, 7, 4. So it's the last one, n squared minus 6n plus 10n minus 60. We're going to factor in n, you get n minus 6. Factor out a 10, you get n minus 6. And we get n minus 6, n plus 10. Oh, this board's about to fall because it is lagging big time down here. Minus 6 and plus 10. I don't know if you can tell the difference when you hear the noise of me. Oh, that didn't work. Look at all this crazy stuff going on in my screen. That maybe was why it was. Those cancel. You're left with n plus 2, n minus 6. And that would be your answer. The 6 and the 2 can't cancel. The n's can't cancel either because they're being added and subtracted. All right, so let's factor that. Some of you are going to get good and understand that it's going to be v plus 1, v plus 5. And the denominator is going to factor to v plus 1, v plus 1. Some of you saw it was a binomial square. Some of you didn't, and it'll still work. The v plus 1's cancel. You're left with v plus 5 over v plus 1. And that is it simplified. So I'm going to run through these relatively quickly now. So I'm going to factor out an 8p, and that gives me p minus 4. I'm going to factor p squared minus 12p. Factors of 32 when added equal 12 are going to be p plus, what do we got, 4 and 8? Yeah, up, minus, signs are the same, both are negative, for p minus 4, p minus 8. So if you can do that, if you can start doing that mental math, that's really good. If you can see those, that factor pairs. Now the 8's can't cancel and the p's can't cancel. So be mindful of that. So all we did was a times c in that denominator. I just was able to do it in my head. So factors of 18 when added equal 9. 6 and 3, so that is x, signs are the same, both are positive. X plus 3, x plus 6. Factors of 30 when subtracted equal 7 are 10 and 3. Signs are different, bigger is negative, so negative 10, positive 3. The x plus 3's will cancel, and that leaves us with x plus 6 over x minus 10. Number 11, ooh, so this is a tricky one. Looking at the numerator, I can factor out a 3 from each of those. So, and an x. So let's factor out a 3x. And we get x squared minus 5x plus 6 over the denominator. We can factor out a 3x also. That gets a x squared plus 3x minus 3 goes into 54. What's that, 18? 18 times? Let's make sure. Calculator, 54 divided by 3, 18. Good. All right, so these 3 x's can cancel, and that leaves us with x squared minus 5x plus 6 over x squared plus 3x minus 18. Now we can still factor those, so you're not done. This factors of 6 when added equal 5, and the signs are the same and both are negative. So that's x minus 2, x minus 3. Factors of 18 when subtracted equal 3 are 6 and 3. Signs are different, bigger's positive. So positive 6, negative 3. The x minus 3's cancel, and that leaves you with x minus 2, x plus 6. And in high school, look, in high school, by your sophomore year, you should be able to do this as I'm doing it. Just as fast, just as efficient. So r squared plus 6r minus 7, that factors to, signs are the same, signs are different, bigger's positive, so x plus 7, x minus 1. So positive 7, negative 1 multiply to make negative 7, positive 7 minus 1 make positive 6. And not x, Mr. Mac. Those should be r's. The denominator, factors of 10 when added equal 11. Signs are the same, both are negative. And we get r minus 1, r minus 10. They have an r minus 1 in common. And that's going to leave us with r plus 7, r minus 10. I'm not going over the 8 times c part because you should know how to do that. At this point, you should be 100% proficient at doing a times c. But that's how I'm getting these. I'm not just making them up. I'm getting them by doing the a times c. I'm just not showing you. I'm doing that in my head. All right, this one we always want to see, is there a common factor? Yep, there's a 2x that we can take from those. That gives us x squared minus x minus 90. Ooh, that's going to be yummy. We'll factor out a 3x. That gives us x squared minus x minus 90 again? Yeah. Okay, that's cool. I like that. Because they are the same quantity, x squared minus x minus 90, we can cancel those. It's being multiplied, and they're the same quantity. So x over x, 5x over 5x, x plus 2 over x plus 2, those will all simplify to 1. And then the x's will cancel, and you're left with 2/3. I like that one. That was pretty awesome. All right, let's look at number 14. I'm going to factor out a 7n of the numerator. That becomes n plus 2. Factors of 8 when added equals 6. 4 and 2. Signs are the same. Both are positive. So the n plus 2 cancel, and you're left with 7n over n plus 4. And last but not least, common factor first. There's a 6 can go in each of those. X squared plus 3x minus 10. A 2x goes into both of those. That leaves you with x squared plus 3x minus 10. Again, we have the same quantities. That's x squared plus 3x minus 10. This is x squared plus 3x minus 10. Those will cancel because they are identical. That's 1 over 1. And then the 6 and the 2 can cancel. The 6 becomes 3. And then don't forget the x left over. So you get 3 in the numerator, x in the denominator. Oh yeah. Good work. Come and see me if you have any questions.